Welcome back to your learning journey in this machine learning. So here, when we talk about a supervised machine learning, the general flow that we follow in machine learning is as follows. First, we'll get the data set, and then we will split the data set into two parts, that is training set and the test set. And once you split the data into two parts, we'll then go ahead and apply the machine learning algorithm on the training data set and generate a trained machine learning model. And then on the new data that I have got, I'm going to evaluate this trained machine learning model and have a validation on the performance, and I'll see whether the machine learning model is working as per the expectation or not. So the first machine learning algorithm that we are going to take a look at is the linear regression algorithm. Now, linear regression algorithm is a type of supervised machine learning algorithm which helps us to find the patterns between the data set. And one of the key things that you need to remember in this linear regression algorithm is this comes under the supervised machine learning. And under the supervised machine learning, we are going to perform the task called regression. So we say that a machine learning task has regression when I'm predicting, when we are predicting a real value. That means if the target output y, which is numerical in nature or the continuous value in nature, at that time we are going to say that we are actually performing the task of regression. So whenever we are working with the data, you just have to check whether you have both x and y. If you have got x and y, then it's a supervised machine learning. And if your y is numerical in nature, obviously it will be a regression task. Now, this linear regression algorithm can be implemented in various ways. I can make use of stats module, or I can also make use of scikit-learn library. To keep it simple, so I'm going to make use of scikit-learn library's linear regression class, and then we are going to apply it on a given data set. So we'll apply the entire flow on that given data set, and we'll try to visualize the data, and then we'll also look into the important assumptions that are made by this linear regression algorithm. Okay, so let's get started and let's have a look into this linear regression algorithm. Here I'm now in my Jupyter notebook. So the dataset that I'm going to use is the advertising.csv file. So this is the file that I'll be using right now. So I'll start by loading the necessary libraries. Import pandas as pd, and I'm going to import numpy. Then I'm going to say matplotlib inline, and we'll also import. Then we'll import the train test split from sklearn.model_selection. I'm going to import train test split. This is the function that I'll be using to split the data into two parts. Then we will also go ahead and load the linear regression algorithm. This is present inside this sklearn.linear_model. I'm going to import linear regression. Now, once we import the necessary libraries, I'll start by loading the data set. df is equal to pd.read_csv, and the file is advertising.csv, and will display first few entries of this data frame. So this is how the first few entries of this data frame would look like. So here on this data, one thing is pretty much clear. So we've got a column that is unnamed 0, which is an invalid column in this data set. So let's go ahead and drop that column. So df.drop, and here the column that I want to drop is unnamed 0. Okay, and I'm going to mention in place is equal to true. So in this way, I'll drop that column and I'll display first few entries for validation. Yes, we have dropped that column. Now, first things first, here we will have to first go ahead and identify what is the given features and what is the target value. In this given data set, the input features are TV, radio, newspaper, and the target column is the sales column. So we are trying to establish a relationship between the spend on TV, radio, and newspaper, and its linkage to the sales of a product. So these X that we call it, these are my inputs, and this Y, that is the sales, is called as the output. From the statistic side, this input is also known as independent variable, and output variable is also known as a dependent variable. Okay, and this input is also known as feature. This output is also known as target. So all these are equivalent words. All these are equivalent words. Input, independent variables, features, all these are equivalent words. These would mean the same thing. And similarly, output, dependent variable, and target would actually mean the same thing. So in case of supervised learning, I need to have both input as well as output. We can clearly say that in this data set, using this, I can actually perform the supervised machine learning. And another key thing is, if you look into the target column, that is the output column, so this column is actually numerical in nature. Since it is numerical in nature, the task it belongs to is the regression task. Are you clear? Excellent. So we are trying to establish a relationship between this X, that is my input, with the Y, that is my output. Now, how do we establish relationship? Well, each and every machine learning algorithm has a numerical representation or a mathematical way to establish this relationship between X and Y. When we talk about the linear regression algorithm, here the linear regression algorithm is given by y hat is equal to a plus b into x. Now here a is a y-intercept term and b is a slope. So this equation that you see right now, this is an equation of simple linear regression. In case of simple linear regression, I'll have only one feature. My x is only one feature. If I have multiple x, that means if I have multiple features, just like you have seen in this example, the equation is given by y hat is equal to theta naught plus theta 1 x1 plus theta 2 x2 up to theta n xn. Okay, here x1, x2, x3, these are nothing but the features. Okay, and theta 1, theta 3 up to theta n, these are the coefficients of this linear regression algorithm, and theta naught is actually my intercept. Okay, this is actually my intercept for this linear regression algorithm. Okay, so what I'm trying to do is, when I perform the fit using the linear regression class, okay, at that time I'll be trying to fit, that means I'll be training my training data such that the x and y are related with the help of this equation. So what will be the outcome? Well, the output that I would get from the linear regression model is coefficients and the intercept, which are nothing but the crux of the pattern that is found between x and y. Okay, so with this basic understanding, let's go ahead and apply it on our given data set. So I'll start by importing the same from sklearn. So since I've already imported it, I'll say LR is equal to linear regression. And here, before I apply the fit on this given data set, first thing is I have to split the data into two parts, xtrain comma xtest, ytrain comma ytest is equal to train test split x comma y comma random state is equal to 4. Okay, and test size is equal to 0.3. So with this way, I'll be splitting the data in the ratio of 70-30. Next, once I split the data, next I'll just go ahead and apply the linear regression model. So I'm actually getting an error. Let me just fix that. So I'll be separating the x and y, df.drop. So I'll say sales as the target column and I'll mention the remaining columns as the input. Okay, I'll be splitting the data in this way, that is x and y. Now once I split the data, if I now display the shape of my x train as well as my x test, we can validate that whether the data has been split into two parts. Okay, it says there is an error. Let's just fix that. Yep. So if you look into our data set, in this data set there are actually 200 rows, and when we have split the data in the ratio of 70 and 30, I've got 140 rows in my training data and 60 rows in my test data. Okay, so this is how I have actually split the data set. Now let's find the relationship between x and y. So lr.fit x train comma y train. Now once I have performed the fit, see, as an output I'll be getting the coefficients. These are the coefficients 0.04533, 0.01, 0.177, 0.00553. So these are the coefficients, and if I go ahead and get the intercept, this is the intercept value. So you can clearly observe that in this example, my machine learning algorithm has got the data as an input and it has generated the parameters as the output. So the patterns between x and y has been learned from this given data set. Okay, now that is the crux of machine learning. Now, once we have trained the machine learning algorithm, this is my trained model. So on this trained model, I can generate the output for the unknown data. So when I say generating the output on the unknown data, what it means is, let's say I've got a new data, let's say test data. Test data is a data where I have actually set out separately, which I'll be using it to generate the output. Now on this test data, I can generate the prediction. So I can say ypred test is equal to lr.predict, and I can send in my x test. Okay, this will help me to generate the prediction using this x test. Okay, so that is how I can generate the output for the unknown data. So I have trained the machine learning model, I've generated the prediction for the unknown data, which is exactly the flow that we have just completed. In case of training, this is how we'll be doing. On the test data, see, I'm generating the prediction. Now once I've generated the prediction, obviously we will have to do the evaluation. So we have to do the evaluation of the linear regression. Now when we talk about the evaluation of this linear regression algorithm, so evaluation functions helps us to measure how well my model is actually performing. Now, depending on the machine learning task, we can actually use the relevant evaluation function. Talking about linear regression, we have got mean absolute error, we have got mean squared error, we have got root mean squared error, and we also have R2 score or the R square value. So let's understand these evaluation functions. See, when we talk about these evaluation functions, so basically the evaluation functions helps us to evaluate whether the machine learning model's performance is as per our requirement or not. So that is the overall idea or the goal of evaluating any model. So to evaluate, I would need to have my true value. I'll call it as y true. This is from my given data set. And I would also have the ypred, that is the prediction from my machine learning model. Now, let's say my y true values are 85, 59, 65, 45, 30, and let's say 98. And my predicted values, so assume that these are the predictions that I have from my linear regression algorithm after I have performed the training on the training data. So my prediction values are 89, let's say 57, 66, 42, maybe 28, and 90. Okay, these are the values of prediction. Now, if you compare it right away, obviously nowhere the prediction values is actually same as the y true. That means there is a difference between the predicted value with the true value that we are expecting. Now, in such scenarios, we need a mathematical way to measure how much mistake that I'm doing. And that is where the evaluation functions comes into picture. The evaluation function in machine learning helps us to evaluate a machine learning model to see and to help us as how it is performing on a new data set. Because at the end of the day, we want to utilize this model on a new data set, which will overall help us in finding the generalization on the data points, which will help us to generate the prediction in a much better way. Okay, now when I have got the predicted value and the true value, if I want to check and evaluate the model, one function that I'll be using is mean absolute error. So when I say mean absolute error, it basically it's the absolute difference between the predicted value and the expected value, that is true value, that is absolute difference between these two values. So if I find the absolute difference between these two values, see 89 minus 85, 4, 57 minus 59, it is minus 2. That means absolute difference is, I'll ignore the negative sign, it will become 2. So 65 and 66, 1, 42 and 45, 3, 28, 32, 90, 98, 8. So in this way, I can find the absolute error, that is the absolute difference between my predicted value and the output value. Now, to generalize with a single value, what I'll be doing is I'll calculate the mean of this absolute error. Okay, this calculation of mean is actually known as mean absolute error. Okay, this is actually known as the mean absolute error, and in this example 3.3333 is the mean absolute error for this given data. Clear? Great. Now there's one more common function that I'll be using, that is called as mean squared error. It's called as mean squared error. So in case of mean squared error, whatever the absolute difference that I'm going to get it, I'm going to perform the squaring. I'll say C2 multiplied with C2, and I'll do the same thing for each and every value that I've got here. See, I've done the squaring. So once I do the squaring, okay, once I do the squaring and then calculate the average of this squared error that I've got, that will be my mean squared error. And in this example, the mean squared error is 16.333. And apart from this, I have mentioned that there is something called as root mean squared error. So root mean squared error is actually the square root of mean squared error. That means square root of whatever the mean squared error that I have got, that will be my root mean squared error. So these are the various evaluation functions which will help us to evaluate a regression task. Okay, now if I want to find these evaluation metric for the given model, so from sklearn.metrics, I'm going to import mean squared error, mean absolute error. So along with that, I'll also import the R2 score. Okay, now in order to calculate the mean squared error, I'm going to write a print function like this: mean squared error y-test, comma y-pred test. And in the same way, I'm going to calculate the root mean square error and the mean absolute error. See, if I want to calculate the root mean squared error, in the same function of mean squared error, I have to send the parameter that says as squared is equal to false. Okay, this is going to return the root mean squared error. And if I want to find the mean absolute error, I just have to call the function mean absolute error, and this will help me to display the mean absolute error. See, for the given data set, the mean squared error is 2.22 and the root mean squared error is 1.49, and the mean absolute error for this given data set is 1.21. Okay, and apart from this, an important metric that we have got, especially during the evaluation of the regression model, is R2 score. So the R2 score tells us as how much variance can be explained by the given features. So variance is nothing but the information. Okay, how much variability can be explained by using that column, that is by using these features about the target column. Suppose if I can predict the complete y with the help of my x, then I can say that there is 100% variance can be explained by the given set of features. At that time, the R2 score or the R2 coefficient will give me the output as 1. So if my predicted line falls directly on the data points, that's when the R2 score will be equal to 1. And if I have the data points closer to my straight line, that is a linear regression line, at that time the value of R2 score will be closer to 1. If the data points are actually distributed in a random way across the line, then the R2 score will be closer to 0. So overall, this helps us to understand, okay, how much variance can I explain from this given data set. So if I calculate the R2 score for this given data, the R2 score is 0.91, which means from this given set of features, that is the values of TV, radio, and newspaper, I can predict with 91% of accuracy, because I can actually explain 91% of variance that is present in this given output variable. Okay, these are the ways in which that I can evaluate my linear regression algorithm. Okay, now once I'm satisfied with the results that I'm getting, I can go ahead and generate the prediction on the new data as well, and I can deploy it as a service and use it for the future prediction. So that is the overall methodology that we will be implementing any machine learning model. In the next video, we will talk about the regularization of linear regression algorithm, and along with that, we'll also look into the assumptions of linear regression algorithm. So I'll see you in the next video.